long way around on this problem. And you know me, either I'm trying to get us to solve a problem in under 3 minutes, or we're trying to deeply understand the skill set, the vocabulary, the notation. And that's what today's lesson's going to be. So we've all been receiving our summer packets for math, and we're preparing for next year's math class, which is actually only in 2 months. So let's get started. This math packet is from a student that's in Algebra 1 moving into Algebra 2 next year. And what I want to challenge you with, I actually saw this great quote today, and I think I saw it on TikTok. And this is, he's obviously like one of the best, the greatest, inarguably, basketball player, Michael Jordan. And he says, get the fundamentals down and the level of everything you do will rise. And when I heard that, I thought he's talking about math. This is so much about mathematics, and this is what I challenge you to do. Over this summer, you want to be getting those fundamentals down, and when you go back to school in fall, the level of everything you do will rise. So when we're solving problems, you're constantly looking for those skills where you have misconceptions, or maybe you weren't paying attention that day, or maybe you were just out and you need to go back. Your generation is so fortunate. Whenever you're not sure how to do something, you've got technology out there like Khan Academy. A lot of you are already registered with IXL. You can reach out to your teacher. There's always some way to fill in that missing skill set, and your job this summer is to find and spot those as you go through your summer packet. Okay, let's jump in. So today's problem, the function is equal to -3 times x plus 2 squared minus 4. And we're going to use this given function below to answer the following questions. What is the y-intercept and the x-intercepts of the function? What are the coordinates of the vertex of the function? What is its axis of symmetry? We're going to write the function in standard form. It's asking, does the parabola open up or down? What is the domain and the range of the function? All right, so you know me. I normally take these problems and drag them into the Polya problem solving process, and we start off with that template. But you know what? That template is just that. It's what really matters with the Polya problem solving process is it is a way of how we go about solving problems. And so we're actually going to stay in this template that we are working in today. And I'm just going to move that over here, copy it. But at the same time, I just want you to keep in mind that the way we solve problems is always using this process. You don't even need this sticker to remember that. You just need to know that you can draw 2 perpendicular lines and just write those 4 statements in there. Understand, plan, try it, look back. Always those 4 statements until it just becomes second nature, until it's just common sense to do it this way. All right, so we're going to start off in that understand phase. I want you to pause the video and think about what do you notice about this problem overall. And then I want you to think about what do you understand about the structure of this polynomial. And when you've given it a good thought, you can write a couple of notes down, but do not jump in and start trying to solve this problem. Just give it a thought about what do you understand so far, what do you notice? Okay, so what I understand is what I notice when I look at this problem with all of its questions. For me, I think I would love to take this function and graph it. And then I feel like I'm a visual person, and if I graph this function, I can answer all these questions right out of that graph. And I'm sure it could probably also just be answered algebraically directly from this equation, but that's what I notice. This is a very graph-oriented set of questions. I don't know if you agree, but if you do, this is the way I'll proceed, and you can feel free to proceed algebraically, and we can always see at the end how our answers look. Now, let's get into the structure of this. I'd say what's the first question is, did you think about the form of this equation? What form is it in? Well, I mean, I don't know how long ago you learned about your polynomials and how long ago you learned about your forms, but there are three different types of polynomial forms. We have the standard form, which I'm sure you remember is ax squared plus bx plus c. We have that vertex form, and it's in that form of a times x minus h squared plus k. And a is a value that tells us whether the parabola is opening up or down. It also tells us how squishy the parabola is or how stretched out it is. And the h and the k values tell us exactly where the vertex is. So with all that information, vertex form has always been a very easy form to use to graph equations, to graph polynomials. And the third form is factored form, and this helps us typically find the x-intercepts. So what do you think? When I'm looking at our problem, I'm thinking that looks very much like, hoping you're filling in the answer right now, it looks like a vertex form, doesn't it? And I'm so happy because that means I'm going to have to do very little work to graph this, and that really fits in nicely with my proposed plan for how to move forward. So we're looking at this and we're thinking, well, a is equal to that -3. And we have x plus 2, and remember it was negative h, but we know then that that 2, it's a -2. And then the k is a -4. So definitely this is in vertex form. Okay, so let's jump in. And so I'm going to start by graphing. Let's see, we're going to take advantage of Notability's capability of having, I think it's under stickies, there it is, the grid. And I always like the color gray for my grids, or the blue is nice. I also like to have the grid size with the most boxes. And this is so handy. I just wish they had a sticky though with the graph chart already drawn out. That would be really nice, but this is still not too hard. Let's see, so we're just going to have to draw a quick line over here. And there we go. And draw a line going up and down. Nice, okay, I'm going to make sure to label, because we should always label our graphs. This is our y, this is our x. Okay, so let me move this down so I can see the function. Now, first thing I want you to be thinking about, what are the points that we need to be thinking about if we're going to graph this polynomial? So pause the video for a second and try to think out, what information do you typically need if you need to make a graph? All right, so what I remember is I want the vertex. I want to know any x or y intercepts. And it's good to know the axis of symmetry. That can help us in making more points. Typically we want to make sure we have about 3 to 5 points when we're making our graph. So just remember, what does it mean to graph? I would, always, my goal is to always think about those steps when I'm in the plan phase before I start solving. Just make sure I have a clear picture of what I'm doing before I'm moving forward. All right, so the vertex, we already said that that's going to be easy. This is going to be -2 and -4. Now, since I only have a small little graph here, I'm going to say that each line is 2 steps. So I'm going to say -2, -4 is going to go here. And that's my vertex. And we know from A that this graph is going to be facing, letting you fill in the blank, downward because it's -3. So we know that negative means it's going to be a downward facing. That probably should have been an additional point that I had over here. Is it going to be down or up? So we've got the vertex. We know whether it's facing down or up. We want to be thinking about our x or y intercepts. Well, the y is very easy. We just set x to 0. And let's challenge ourselves to do this mentally. So if I put x is equal to 0, I'm going to have 2 squared, which is equal to 4. 4 times -3, which is equal to -12. -12 minus 4 is -16. There you go. And we know that the x is 0, so this is 0, -16. So I'm going to go 2, 4, 6, 8, 10, 12, 14, 16. And there is my y-intercept. And so, wow, this is going to be a very narrow parabola, isn't it? Oh, I didn't mean to get a straight line there. Notability, thank you, but I really need it to be slightly curved. Now, we talked about the axis of symmetry. We know that's going to be where x is, which is -2. And why I wanted to bring that up right now is that's going to give us another point. Because if we know that one point is at 0, -16, well, then we know that this distance to the axis of symmetry is 2. And so we know if we hop another 2 that we are going to get another point. And this point's going to be negative, because we hopped 2, so it's going to be -4, comma, -16. And so again, we see how this is such a, just having that -3 makes it a very squishy. And also the fact that I'm skipping my 2's, I'm sure isn't helping. And there's my parabola. You know, what's interesting is really I wanted to find my x-intercepts, but what do you notice from this graph? What can you say about the x-intercepts? Pause the video if you need to and think about this for a sec. Okay, so there are none. I mean, at least there's no real x-intercepts, any x-intercepts that are real numbers. There are imaginary ones, and we could definitely calculate for that. But for the purposes of what we're doing, no, we don't need to have that answer. We can just say, no, there's no real x-intercepts. And so we have our 3 to 5 points. We have our axis of symmetry. We have our intercepts. We've got a perfect graph. Let's go around and start trying to solve the questions using it. All right, so we're actually going to try this. So what is the y-intercept of f? Well, we said it's 0, -16. Remember, when it's asking for y-intercept, we want to give it a point. 0, comma, -16. That means we want a coordinate, and it should have an x value and the y value. Okay, let's see. Let's move this over here. What are the x-intercepts? There are no real x-intercepts. Very exciting. Okay, so we're going to move this over here. What are the coordinates of the vertex? Oh, this is great, isn't it? This is so easy. So we're going to just get that vertex over here, which is -2, comma, -4. And I would love to know how you guys are doing if you chose not to make a graph and you chose to get the information straight from the function. Is it coming in easy? And I think so over time. If you have a good, solid visual representation in your mind of what that algebraic function is going to look like, you might be able to hop over and skip over drawing a graph of it and just answer the questions. But I think a good first step is to get that visual representation, especially since this is something we might not have seen for a few months. All right, what is the axis of symmetry of f? So we said that that's going to be where x is equal to -2. Write f in standard form. They want us to write the function in standard form. We're not going to get that from the graph. Let's skip over that one for now and just see what other questions can't be answered from this graph. Does the parabola open up or down? That's an easy one. Down. And let's keep bringing this along with us. What is the domain of f? Boy, do you remember your domain and ranges? Well, remember with domain, we're going across the x. So we're looking to see how far to the left and how far to the right does this parabola open up. Now it looks very squishy and it looks like it's barely making it past the -4x value, but we know that over time it's just going to keep moving to the left. This is going to keep going outwards very slowly. But if we go all the way down to, I would say like 1,000,000, it's definitely going to start stretching out to infinity. So the domain of f is going to be, on the left-hand side, it's going to be -infinity. And the same thing's going to happen on the right-hand side. This is just going to keep going and going and going. So it's going to be positive infinity. What is the range of f? Well, now we're going to do that same thing. We're working bottom up, and we're thinking about what is the limit of the range of this function. Now we started down here thinking about it's just going to keep getting lower and lower across that y-axis. So again, this is -infinity. And the top, though, as we keep going up, we see that the vertex stops at -4. And now here's the thing. I was telling you about skills. Please make sure that you quickly review your interval notation. You might be able to just go over to Khan Academy, or if you have IXL, just make sure to practice some problems. And remember that when we get to -4 and we want to use interval notation, since -4 is, thank you, Notability. Let's try that again. Since -4 is included in the answer, on the right-hand side, we're going to use square brackets. And that's it. We did it. We just have one more question that couldn't be answered by our graph. So what we could do is just kind of squish our graph up. I wouldn't get rid of it. I would keep it and hand it in as part of your answers. And let's just move this all the way up. We can keep them over there. Now, write f in standard form. So let's just make sure we remember this formula. Okay, I have it down. So we're going to take f of x is equal to -3 times x plus 2 squared minus 4. Now there's really no tricks or shortcuts. We have to take this function, we have to expand it, and then we have to combine the like terms. And from there, we might even have to pull out a GCF to get it into standard form. So let's do this. So the first thing we want to do is expand it. So we're going to say -3, and we'll say x plus 2 times x plus 2. And we're doing that because we have that exponent that's 2. So that means we want 2 sets of x plus 2. And we're going to say -4. Now we're going to use the distributive property to further multiply this out. So if you remember that, we're going to take the x, multiply it by the x. We're going to take x, multiply it by 2 using the distributive property. We're going to take the 2, multiply it by x, 2 times 2, and let's see, so we will get -3 times x squared plus 2x plus 2x is equal to 4x plus 4. Now, if you do not remember the distributive property, please, again, make a little note for yourself and make sure you fill in that skill set over the summer, doing lots of problems to just get that nice and familiar. Make it so that it's right at your fingertips, and that's going to really help you next year when you go back to school. All right, so we have the -3 now has to get distributed out across that equation. -3 x squared plus, I wouldn't say plus, jumped the gun there. -3 times 4x is -12x. -3 times 4 is -12. and minus 4. Okay, the next step, now that we've expanded that equation out, now we've got to combine like terms. And the only like terms that I'm seeing here are the constants. So let's combine those. So we have negative 3x squared minus 12x minus 16. And that's it. That's our function. Now we've got one more step to make sure that it's in standard form. I don't see any common factors, let alone a greatest common factor. So I'm actually really happy with this as my final answer. And that means I'm done. You know, I have a couple of notes for myself. I know that I want to, if I don't have distributive property down, my interval notation down, or I couldn't remember the forms, make sure to get a sticky right now and put yourself a note and make sure you schedule some time this summer, I would say within this week, to go to Khan and go learn those things and make sure you have them solid. Or if you have IXL at your school, go practice. All right, so we're done, but we're not done, right? We have, I know you know what I mean. We understood the problem, we planned it, we tried it, we solved it, and we are now going to look back at our work. Now, we ask ourselves first, does this answer hold water? And, you know, I think because we spent a lot of time thinking about this, I don't know that I want to take this much further. What I would recommend, though, is to give some thought in terms of the approach and how does that hold up against others' approaches. And so a lot of times the summer packets don't give you the answers, okay? And so one thing you could do is you could call a friend and see what they did and see how they answered this question. Another thing you could do, though, is also just, you know, bring this into Desmos. Now, I don't recommend ever, like, the objective is not to cheat. You know, it's not to use these packages to get the answer, but more just, you know, as a way to check your answers and to understand, did your approach, how does it hold up against others' approaches? And one thing that's great about Desmos is you can quickly see, like, oh, that's exactly what I thought, you know, this graph would look like. You don't want to use it to tell you what the graph would look like, because then you're going to end up going back to school and your foundations will not be there and it's going to be a tough year. You're trying this yourself, and then you're reaching out to these wonderful technologies to see if your steps made sense, to see if your answer made sense. You're reaching out to friends to see the same. Okay, so I think that's about it. I think we're going to wrap up. When we look back, you might want to spend some time wondering any questions you might have about this formula. Nothing really pops out at me with this because it's not really a word problem. So this is really a skill-based problem. And of course, the one thing I always love to do when I'm done and I'm happy with all of the work that I did, I give myself a congratulatory sticker. And so we go back to, we're in the summer math, there we go. And paste. And I'm giving myself that I'm all kinds of amazing, because that's what you are, for doing this work over the summer and really spending time and making sure you get those foundations down. So if you have any questions, please put them in the comments section. If you have a summer problem that you're struggling with, throw it out to the comments section and we'll see if we can include it in the next How to Solve It. Now, one thing you could do as a next step is you could try to solve this in under 3 minutes now that you have that visual representation and now you're starting to remember everything. Try to solve this problem again, but this time try to do it in under 3 minutes. Don't take the long way around. We've done that today. Another thing you could do is, I have one more problem that is very similar to that one, and I could show you it here. If you take a look at that, take a snapshot of it, and you give it a try now. You try to solve this, and let's see if you can do this using the techniques that we covered today. I hope you have a wonderful math summer.